Welcome, guys. Welcome. Good evening. Welcome, everyone. You are powerfully welcomed. Uh, Welcome to the grand finale of permutation and combination. So tonight is going to be lots and lots of questions, loads of questions. All right. Odun, I cite you. Fermi, I cite you. Elendu, I cite you. Adebola, I can see you. Welcome, guys. You're powerfully welcomed. Intense and workings today. You guys are going to deal with lots and lots of questions of different level of technicality. So be very much ready. Hold your pen, grab your piece of paper and your calculator, and make sure you are very much ready to deal with any form of question. Foxy, you're welcome. All right. So we started. Let's start with the question we have right in front of us. This was the question we were solving before the network went out. I could see you guys answer. I was seeing your answers, but of course, by the way, do I talk about Arsenal and Man City? No, let's not talk about that. So let's talk about this right in front of us. Let me see the answers, you guys. I saw different answers yesterday. I would love to see the answers you guys gave. So what were your answers to this question? What were your answers? I saw 1,440, and somebody commented that, how are you guys getting this large number? All right, yeah, I saw those answers. Somebody said 21,600. Okay, do we have other answers? Can we drop it in like 30 seconds? Okay, 30, yeah. I think those are some of the answers that were. All right, any other answer, any other variant? Okay, so let's get right into it, guys. Let's read the question carefully and let's solve it. There are 5 books and 4 bags. 5 books, 4 bags. 5 books, 4 bags. All right. Always understand the context of the question. So we have 5 books somewhere. We have 4 bags in the same place. Now the question said, in how many ways can 4 books and 2 bags be arranged on a shelf? Guys, are you seeing something here? This question is one of those questions you should expect in an A-level exam because of the level of technicality. This is a very technical question because it comes with the application of both permutation and combination. Look at it, guys. In how many ways can 4 books and 2 bags? If you look at what's going on here, you are selecting, because you have 5 books, you have 4 bags. So obviously, you are selecting 4 books out of these 5 books, and you're also selecting 2 bags out of these 4 bags. But don't forget, you're not just selecting, you're not just creating a team here, you're also arranging it on the shelf. So you're concerned about selecting, you're also concerned about arranging. Does it make sense? So you want to select, you want to make these 4 books more like, imagine your I told you about combination being having something to do with creating a team, creating a committee. So it's more like you're interested in creating, let's say, a team that is supposed to have 4 books and 2 bags. That's the prerequisite for your team. 4 books and 2 bags. Now, after creating that team, now you've created the team. Now, let's say you created a team. The team had book 1, book 2. Out of these 5 books now, it had book 1. Let's assume this was the team you created. It had book 1, it had book 3, it had book 4, it had book 5. Let's assume this was, of course, book 2 was the only one that was not selected. You created a team that has it. And then let's see the bag. Let's say the bag was, let's call the bag BA, 2 bags. Let's say the bags featured bag 2 and also featured bag 4. So this bag had, so this was the team you selected. Let's assume this was, of course, this is a possible selection. All right. So you selected, this is 4 books here. This is 2 bags. Of course, this all came out from this. Now, based on this question, you're not just concerned about selecting, you're also concerned about arranging. It said, in how many ways can these books, these bags, be arranged on a shelf? So after selecting them like this, you are still concerned about how many possible arrangements can you bring out from, this is a selection now. How many arrangements is possible? Of course, you have 6 objects here. So, and you're arranging the whole 6 of them. So that will be 6 factorial ways. So this happening can happen in 6 factorial ways. This particular selection, what I mean by this is that it's possible you start your arrangement with bag 2, and then you go on to book 1, maybe book 3, then you have bag 4, then you have book 4, book 5. Now, this is an arrangement. Are you seeing that? This is an arrangement that is possible. You can have other many different arrangements. It's possible you have book 1, then bag 2, then maybe bag 4, and then book 3, book 4. That's what this question is talking about. It's asking you to select this object and also arrange them. So it's a question that has to do with both permutation and combination. You have to, of course, do the selection first. So let's try and do the selection based on our understanding on selection, on combination. We have five books. We are selecting how many of them? Just 4. So, and we are also having 4 bags, and we are selecting 2 of them. This is if we're not concerned about arranging, this would have been the answer. If the question was like, in how many ways can you select 4 books and 2 bags? This is the answer, which I believe everybody understands that already. But we're not concerned about just selecting them. We also want to arrange them. Now, if you look at, and I'm sure you understand this already, this selection has a total of 6 objects. So the question is, each of this selection, how many ways can you arrange them? As I said, let's say this was one selection now. This is a possible way of arranging. So what you just have to do to get your final answer will be to multiply this by 6 factorial. This is what will bring out your answer. Can anybody do this and tell me your final answer? So this is helping you with selecting it. This is what we arrange it. Of course, you understand that this 6 factorial I wrote is representing 6 arranging 6, because you have 6 objects and you're arranging the 6 of them. So this is what will give you all the possible arrangements that you can possibly have. If you solve this, you get a total of 21,600. Does it make sense? This is how you deal with questions around both permutation and combination. So I'm going to give you another question. This one, all the best in solving it. I'm going to see how you guys fare in solving this. All right. Look at the question very quickly. If N4, N5, N6 are first 3 terms of a linear sequence, so the question is, of course, you know what the linear sequence is. Find N, and question number 2, find the common difference of the sequence. So let me see who gets this answer. All right. So the question said, if what you have here, I'm not going to say what this is because I explained it yesterday. You guys remember what I said about this. If this are the first 3 terms of a linear sequence, of course, you are told to find N and find the common difference of the sequence. Let me get an answer in 2 minutes, or probably let me make it 3 minutes. Do we have a correct answer yet? Somebody is getting n as 6. Johnson got n as 6. Foxy got n as 6. William got n as 6. Hope you guys are not using any external force. Okay, somebody else said n is 8. Okay, somebody said, okay, he's still solving. Okay, we are waiting. Actually, I expect that you're going to use quite a number of time to solve this. So let's still wait. Please ensure you put, okay, let me just, for the sake of progress, let me give you some hints. Of course, you know that this is n, 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 and you know this stands for n combination, right? So this obviously is n combination 4, n combination 5, and n combination 6, right? Now, look through on this and understand what's going on here. They said these are the first 3 terms of a linear sequence. So you see the context, first 3 terms. First 3 terms. What does it mean? That means we have the common difference as the subtraction of, that means we are good to say the common difference is going to be n, this minus this. And of course, you know what common difference means. Common difference means it must be common. So this minus this must be equal to this minus this, since they are the first 3 terms, since they are consecutive terms. So n combination 6 minus n combination 5. All this represents the difference. So this is correct. Of course, D, this is D, this is D, and D must be equal to D. So if you can understand what we're doing right there, right? Okay. So use this concept now. For those of you still solving, come with this concept and go on to use this to get your answer. So now that you know that this is equals to this can give you a better understanding, right? Because now you can see that you can go on to say n combination 5 minus n combination 4 minus n combination 6 plus n combination 5 should be equals to 0. All right? And if you look at this, you can obviously see that this is n combination 5, this is n combination 5. This will give you 2, of course, 2 of n combination 5. That's 2 n combination 5 minus n combination 4 minus n combination 6 equals to 0. I'm sure you understand what's going on here. This is just basic algebra, all right? So don't forget, this first 3 terms was what gave me my hint to bring out this expression. All right. Now, from you bringing out this expression, I can go on to solve this using my normal understanding of mathematics. That means I brought all this to the left-hand side, and then I brought this out. So the next thing you have to do here is to now use your knowledge of combination. So I'm sure you agree with me that this will be equals to n factorial over n minus 5 factorial, 5 factorial minus n factorial over n minus 4 factorial, 4 factorial, then minus n factorial over n minus 6 factorial, 6 factorial equals to 0. You can see what's going on here. So I believe you've taken a question down. You have to find n and you have to find a common difference. So I want to take this off so that you can use this space quickly. So now the next thing you want to do now is for you to solve this using your knowledge of combination. Now, looking at what is going on here, you will be looking for ways to eliminate all the various elements you are seeing here. So, and if you can look carefully, one of the things I would love to do is to, look at this. You guys need to be very, you can do, by the way, you can move through with different pathways, but we'll still arrive at the same answer. So you don't have to follow my own pathway, all right? You can do anything that works for you. One of the things I want to do quickly is, I see n minus 6 here, I see n minus 4 here. I know for certain that this n minus 5 factorial, I know n minus 5 factorial is the same thing as n minus 5 times n minus 6 factorial. Because obviously you understand the concept of factorial. You will keep subtracting 1. If I subtract 1 from n minus 5, I'll be getting n minus 6. I can leave it here. And I also know that n minus 4 factorial will be the same thing as n minus 4. I subtract 1, it will give me n minus 5. I don't want to stop here because I want to bring everything to having n minus 6 so that I can easily cancel n minus 6 out of this place. So I have n minus 6 factorial. I'll stop it here. So the reason why I did this is because it makes it very easy for me to now write this. So instead of writing n minus 5 now, I'll be writing it as what I have here. So at the end, I'll be able to multiply through by n minus 6 factorial. And when I do that, it will eliminate that side of things. And then I will have a less complex work. So I have 2n factorial over n minus 5, n minus 6 factorial, 5 factorial. I'm representing n minus 5 factorial with this. Of course, minus n factorial over, now I'm representing n minus 4 factorial with what I have here. That'll be n minus 4, n minus 5, then n minus 6 factorial, then 4 factorial. I'm sure you know this division covers everything. Then the last one there, of course, I'm not doing anything here because I can already see that n minus 6 was what was here. So now, of course, there's an equals to 0 here. Look at what happens next. I multiply all through by n minus 6 factorial. All right. So look at this. By the way, I'm going to say something that is very important. Look at, I'm multiplying through by n minus 6 factorial. So I multiply by n minus 6 factorial. You do the same thing for this 0, n minus 6 factorial. Let me write it beneath. Because you don't, when you're trying to solve questions like this, you must ensure that you are following everything mathematically. So you multiply all through everything by n minus 6 factorial. So you multiply all through by n minus 6 factorial. So at this point now, I can go on to make the division, the cutting. This will cut this. This will cut this. Of course, this will also cut this. And 0 times this will be 0. So that will still be 0. All right. So now the next thing is for me to write out the resultant. Let me do something quickly because I want to economize the space. I'm going to do something also. I'm going to do it here. Then I'm going to tell you what. Look at it here. The same way I did for n minus 5, I could also do for 5 factorial. If I go on to, I can bring 5 factorial. I can represent 5 factorial to be 5 times 4 factorial. I can represent 6 factorial to be 6 times 5 times 4 factorial. Of course, if I do this, that means this will turn to 6 times 5 times 4 factorial. The reason why I'm doing that is because I want to be able to cut out 4 factorial. So look at this. I will also be writing this as 5 times 4 factorial. So you can see what's going on there. So I will also do the same thing. I'm going to multiply through with 4 factorial. So I'm going to multiply each of all these things with 4 factorial also. Multiplying this with 4 factorial and this also with 4 factorial. Please don't mind the congestion. We're just trying to So 0 times 4 factorial, this one will still be 0. So the right hand side will still have 0. But one thing that would have happened is that this 4 factorial will cancel this 4 factorial. This one will cancel this one. And this 4 factorial will also cancel this one. So let's bring out the resultant now. So try and check through on what is left. This is equation involving combination, and that's, you have to be very ready for questions like this. This could just come out in a theory question and you have to solve it. So I'm left with n minus 5 here, not factorial now. You remember that the factorial has been cancelled, and I'm left with times 5. 5 is still left here, times 5. That's what is left out here. I have minus n factorial over, I'm left with these 2. That's n minus 4, n minus 5. Of course, that's all. We don't have any other thing left there. Then I have minus n factorial over, I have 6 times 5, then equals to 0. Can you see how this works very fine? So look at what we have now. We have something we can work with quite easily. So now, if I want to do something nice, I could go on to, of course, multiply through by, anyhow you want to do it, whatever works for you, but I will first multiply through by 5. The reason is because I can see 5 here, I can see 5 there. So again, I told you already, different roads will lead to your answer here. I multiply everything by 5, then by 5. Of course, what's going to happen is that you're going to see that this 5 will cancel this. This 5 will cancel this. So you'll be left with 2n factorial over n minus 5. No longer having 5, n factorial over, and this will be 5 now, 5n factorial, n minus 4, then n minus 5, then minus n factorial over 6, everything equals to 0. Are you seeing how gently we are solving? This is intentional so that we would be able to, of course, you all can see what's going on. So can you see something that can happen also? I can multiply through with n minus 5, n minus 5. I multiply both sides, everything by n minus 5, n minus 5. This one also n minus 5. Of course, this one also n minus 5. Are you seeing what's going on right here? So that's the way, when you solve gently, you don't get to make horrible mistakes. So now we have this cancelling this. We have this cancelling this. Of course, this turns to 0. So I have 2n factorial minus 5n factorial over n minus 4 minus, now we have n factorial, and we have n minus 5, everything over 6. All right. Again, some people may decide to just do everything once, but again, we are doing it step by step so that every viewer can understand the basics of what's going on. So one of the next thing I want to try to eliminate now is, don't forget to put your equals to 0. So one of the next thing I want to do now is to divide through, or anyhow you want to say it. I will say multiply through by 1 over n factorial. That means I'm dividing everything, or anyhow you want to say it. Multiplying through means I'm multiplying each of the elements with 1 over n factorial. That means I want to eliminate the n factorial. So I multiply this with 1 over n factorial, multiply this with 1 over n factorial, multiply this with 1 over n factorial. The same thing goes for the 0. You see what's going on right here? So now what's going to happen basically is that the n factorial will be cancelled out, n factorial will be cancelled out, n factorial will be cancelled out. You can see that step by step, you don't miss it out. So looking at what's going on here, I can easily now go on to write the result, and I'm left with only 2 here. I'm sure you can realize that. So this is 2 minus, I'm left with 5 over n minus 4. You can see that clearly. I prefer to put this in bracket, being a compound expression, minus n minus 5 in bracket also over 6. Everything equals to 0. So you can see what's going on now. So the next thing I want to do is step by step. I can decide to do everything once if you want me to. I want to multiply both sides with if I want to do it in a compound way or step by step, whichever one, I want to multiply through with 6 so that I can multiply through with 6, multiply through with 6. You can see what I'm doing there. So this will turn to 12 minus, that should be 30 over n minus 4. All right, and this will cancel out. I'll be left with n minus 5. You see the reason why you have to always maintain your bracket, because if I did not maintain my bracket, this would have given me minus n minus 5, which would be wrong. All right, so you can see what's going on here. The last thing I can do here is to multiply through with n minus 4. I can multiply through with n minus 4. So that way, I'll be able to eliminate the n minus 4. So multiply through with n minus 4 everywhere, n minus 4. You see the way I'm putting this everywhere is to ensure that there are no mistakes. You don't multiply one side and leave the other side. So this will obviously result to 12 into n minus 4 being equals to, this will cancel out. Sorry, not equals to yet. That will be minus 30. Then minus, we have n minus 4, n minus 5. Whichever one you want to put first equals to 0. I'll write it properly on top. But you can understand what I was trying to do there. So obviously we have a much more easier expression now, and the expression is 12 into bracket n minus 4 minus 30 minus, we have, of course, I want to put this in a whole big bracket because I don't want to make a mistake, n minus 5, then n minus 4. Everything is equal to 0. The next thing to do now is to solve this. Of course, you obviously will result to a quadratic expression. But one thing you want to do is to bring out all the openings. This will be 12n. You open all the bracket, minus 48, minus 48, minus 30, minus, let me put this in a bracket and open this out. This should give you n squared minus, I don't want to waste time, this will be minus 4n, minus 5n, that'll be minus 9n plus 20, all right? Equals to 0, don't forget that. This will be 12n minus 78. It's okay to write that. Then I open this bracket with n squared plus 9n minus 20 equals to 0. So this is very much going well. So you can see how moving step by step, we don't seem to make any mistake. I believe our work is quite neat, and it's easy to trace your error when you work this way. Now, one of the things you have here is you want to bring out all your light. You see this and this will move together, and this will result to minus 98. 12n can move with 9n. So we'll be having minus n squared. Then this will give me plus 21n. And this will give me minus 98 equals to 0. You don't like to start your expression with minus, so you want to multiply through with minus. This will be n squared minus 21n plus 98 equals to 0. All right. So you want to solve this using your normal factorization. I believe that will work. If you will solve this, one of the things you will get, the two factors should be minus 7 and minus 14. All right. So that will be n squared minus 7n minus 14n plus 98. I guess so. So at the end of this, you will be getting n minus 7 and n minus 14 equals to 0. So your n will be equal to 7 or 14. All right. So those people that gave the answer as n equals to 7 or 14, they were absolutely very correct. That's the way you solve this. So the next element in the room now is for you to deal with the difference. Now, do not forget that we have two formulas for the difference, and you can use any of them, either of them. One of the first formula, if you remember at the start of this whole expression, one of our difference was n combination 5 minus n combination 4. The other was n combination 6 minus n combination 5. So let's choose to use this. Of course, if our n was 7, that will be 7 combination 5 minus 7 combination 4. And that will give me a total of 21 minus 35. That will give me my difference of minus 14. All right. Now, if our n was 14, not 7, this was for 7, then we'll be having 14 combination 5 minus 14 combination 4. So this will give me 2002 minus 1001, which will give me a total of 1001. All right. So this was one of the questions that I believe they solved. What are you guys talking about? The dog, right? Yeah, the dog is enjoying itself. So that's it. Can you see how just one question can be a bit very simple? I'm sure you guys admit this is quite very simple, but it comes with you being very tactical and consistent. All right. So look at this. How many of you understood what I just did? You really have great understanding of what I just did. Can I get feedback? How do you feel about this question? How do you feel about the solution? Were you able to follow along? Okay. This is P right here. It's 40. So you're going to have just 2 minutes to solve this question. So look at the question, very simple. The coefficient of x squared in 1 minus 2x raised to the power of p is 40. Find p greater than 0. Can you solve that? Just 2 minutes. Let me get your answer in like 2 minutes. No answer yet. You have to find the value of P. All right, that's really great. Okay, so let's look at it together. It's quite very simple. You have to solve, you have to have a background in binomial expansion. And I'm sure you guys have great understanding of binomial expansion. So look at this. Just as a recap, if you have a general binomial expansion of a plus b raised to the power of n, this is equals to r equals to 0 raised to the power n combination. I'm sure you remember this. A raised to the power of n minus r, and then b raised to the power r. All right, so when you have 1 minus 2x raised to the power of p, this will obviously be equals to the same r raised to the power 0. In this, at this time now, not moving towards n, because your n here is p. Moving towards p, and then you'll be having p combination r, and then you'll be having your a is 1 raised to the power of p minus r, because your n here is p, and then you have minus 2x raised to the power of r. So in this case, you're interested in finding the value of p. And you have to understand one thing. You were told that the coefficient of x squared in this expansion is actually 40. Now, the question is, what's the coefficient of x squared? Looking at this expansion right now, what is going to be the coefficient of x squared? All right, for you to get x squared, you can only get x squared if your r was 2. Because look at it right here, you have minus 2x. If your r was any other thing other than 2, you cannot get x squared. So the only way x squared is going to come out is if your r was 2. So go on now and solve for when r was 2. So if r was 2, that means you'll be having p combination 2. Of course, this I'm sure you understand all this. I'm no longer doing the summation now. I'm going straight to picking for when r was 2. In the theory I gave you, I believe we used k. But of course, you could use k if you use r. We are using r here. You can decide to use k. Whichever one works fine. That's p combination r, no longer r now. P combination 2, 1 raised to the power of p minus 2. All right, then minus 2x raised to the power of 2. Now, if you look at what's going on right here, you would be able to perceive that you're already getting closer to your answer. Because at this point now, you can have p combination 2. Now, look at what we have here. This is 1 raised to the power p minus 2. Guys, let me ask that question generally. 1 raised to the power of 10 is what? What is 1 raised to the power of 10? Can we get an answer quick? 1 raised to the power of 10 is what? What's 1 raised to the power of 10? What then? If you answer that, then what is 1 raised to the power of 100? Then what is 1 raised to the power of 100? Then what is 1 raised to the power of 1 million? Now, if you look at the pattern, you see that 1 raised to the power of anything is always going to be 1, apart from it being a negative answer. And you cannot have a negative answer here because there are only two possible situations here. if your P was even 2, let's say your P was 2, all you will have is 2 minus 2. Of course, don't forget, understanding the theory of binomial expansion, P can never, well, in this case, because you already be told that P is greater than 0. So if P is greater than 0, it's not possible for P to be less than 2, like maybe 1, and then you should have R as 2. I'm sure you understand the principle of binomial expansion. For instance, if P was 10, then R is going to be a value lesser than 10. So there are only two possibilities: either R was equals to P or R is less than P. And if P is more than R, which in this case R was 2, your value will always be positive. And if P was actually R, that means let's say P was 2, your value here will still be 0, and 1 raised to the power of 0 is still going to be 1. So with that, you know that already your value here will still be 1. So it will always be 1. The only reason why it may not have been 1 is even if it was negative, 1 raised to the power minus 2, of course, it would have been 1 raised by, even if it was negative, you are still going to get your value, because 1 raised to the power minus 3 will be 1 over 1 raised to the power 3, which is still 1 over 1. So in the end, this will always give you 1. All right, good. Now, this is minus 2x. This is minus 2 raised to the power 2, then x raised to the power 2. Now, this is what you are concerned with, because they said the coefficient of x squared in this expansion, this all here, minus 2 squared is what? Minus 2 squared is 4. Let's just write 4 there. All right, minus 2 squared is 4. So all this is what you are concerned with. This is the coefficient of x squared. And they told you that the coefficient of x squared is 40. That means you are saying 4p combination 2 is equals to 40. In this case, now you can see that p combination 2 is equals to 10. That's dividing both sides by 4. So p combination 2 being 10. We did this yesterday. What's going to be your answer? If p combination 2 is 10, how do you solve for p? P factorial over p minus 2 factorial, 2 factorial equals to 10. All right. So what do you want to do? You want to reduce this. That means you have p minus 1, then p minus 2 factorial. You stop it at this place because you can see the denominator as p minus 2. Everything over p minus 2 factorial, then 2 factorial equals to 10. Don't forget, this will cancel this. We are left with p minus 1, not 2, p minus 1 over 2 factorial, which is still 2, equals to 10. All right. So that means p times p minus 1 is equals to 20. So in this case, now you can see that p squared minus p minus 20 equals to 0. If you solve this, you will get your answer to be p plus 4 and p minus 5 equals to 0. Of course, your p will be equals to minus 4 or 5. Now, if you don't understand the concept, what is 4p? This is 4 times p. 4 times p. Right? 4 times p, not 4p. 4 times p. This is 4 here multiplying this whole thing. This is 4 times p combination. So you divide both sides by 4. You are permitted to do that. All right. So now look at this. P is minus 4 or 5. You could never have your p to be minus 4. Not because you cannot have a binomial expansion of minus 4, but you can never have this place. You cannot have this in this case. And by the way, you could actually have p as minus 4, but that would be a different kind of question, negative power. But look at the question they gave you. They said p was greater than 0. So if p was greater than 0, this cannot be greater than 0. So 5 will be your answer. So p is actually equals to 5. Are you guys seeing how testing some of this question could be? How many of you got this before I solved it? You understood it before I solved it? And how many of you understand it now? All right. You understand it now? Can I get your feedback? Okay. That's great to know. So now it's time for us to launch into the barrage of questions I told you guys about. So you're going to have just you're going to have like just maybe 60 seconds, and this is going to be just 60 seconds. By the way, we're going to be having giveaway, so prepare your mind. We're going to be having that, and be very smart, because it's going to be open to everyone. So all right, so you have lots of questions to solve. Lots of questions, lots and lots of questions. In the next 1 hour, we want to deal with those questions, and I believe you will gain so much from being a part of this. Do we have MTN users there? I want to do. Okay, sorry, you have MTN users there? Okay, I'm going to the fastest finger gets on before we launch into what we're doing. Fastest finger. It's fastest finger. Oh, if you like me, look and well. Oh. I'll see who gets this. So I go permutate something. Oh, quite funny. Are you ready for the last three? The answer here is all right. That's the very first for tonight. So if you can't solve that, you can't answer. Of course, you can't get it. Once you get it, let me know. Let me know if you. Let me know the winner. If you have won, you just let me know. Let me know. Who has gotten it? Who got it? Okay. Who got it? Who was the person that got it? I think I saw somebody writing I got it there. Who was the winner? Don't worry, Hetel is coming. Oh, Anime Vi was the one that got it. So we have to be very fast. I want to see answers falling into this chat box. So find the number of triangles which can be formed by joining the angular points of a polygon of 8 sides as vertices. The number of triangles which can be formed by joining the angular points of a polygon of 8 sides as vertices. Okay, Neo Vibe. Okay, Neo Vibe was one that got it. Congratulations, Neo Vibe. That's great. Okay, I have different answers pouring in. Some people said 56, some people said 70, some people said 336. Somebody said 56, somebody said 56. Okay, we have so many 56. So the question said find the number of triangles which can be formed by joining the angular points of a polygon of 8 sides as vertices. So we have a polygon of 8 sides. I think I did a very similar question sometimes back, probably yesterday. We have a polygon of 8 sides, and you're trying to form a triangle. How many sides does a triangle have? So with all these points, of course, we have 8 different points. So how many points do a triangle need to form for it to be formed? A triangle needs just 3 points, right? 3 points. So that means you need to select out of these 8 points. For you to form a triangle, you need to select 3 out of them. So for each of these team, I like to use the word team because you guys can understand it with that word team when you are trying to combine something, probably forming a team. So obviously, for each of these triangle, you need 3 points. So 8, you are choosing 3 out of them. This will give you the value of 56. Great. All right. So take this question. Also, we're going to be. So look at this question. 3 gentlemen and 3 ladies are candidates for 2 vacancies. A voter has to vote. A voter has to vote for 2 candidates. So the question is, in how many ways can one cast his vote? So look at the question. 3 gentlemen and 3 ladies are candidates. 3 gentlemen and 3 ladies are candidates for 2 vacancies. So you have 2 vacancies. Now a voter is going to ask to vote for 2 candidates. A voter is going to vote for 2 candidates. Now, how many ways can this voter, cast his vote? Okay, so of course, I'm sure you understand the context of this. We have 3 gentlemen, we have 3 ladies. That means we have a total of 6 people. So 6 people are seeking to get 2 vacancies. So this is the number of vacancies, this is the number of people that are existing. So a voter will come now and vote for 2 candidates among these 6. Of course, he has to vote for 2 candidates. So among these 6 now, this person comes and chooses, selects, combine 2 people. So that means obviously looking at the way it's even being read, that will be 6 out of these 6 people, this voter will be choosing 2. That will give you a total of 15. So there are 15 different ways of getting this done. Looks like some of you are getting everything. That's nice. Very nice. Now, this question will probably, you would require, I would really love you to think well before issuing the answer because it comes with a little bit of technicality. So a 2-member committee comprising of one male and one female member is to be constituted out of 5 male and 3 female. So look at what we have right here. We have a 2-member committee, and this is the number of people you have. Now, amongst this female, there is one woman there. Among the females, there is one woman we call Miss A, MS, Miss A. Miss A refuses to be a member of the committee in which you see what's going on right here. So Miss A is refusing now to be a member of the committee in which wait, I don't understand. The answer I'm seeing, is it for this or for something else? Oh, okay. You know, you guys, this thing you are doing, please don't do it in the exam hall. Actually, that answer is not correct. Okay, so the question is, in how many ways, in how many different ways can a committee be constituted? So let me read the question so you can probably hear it in case you need to hear it. A 2-member committee comprises of 1 male and 1 female. So this committee needs 1 male, 1 female, all right, as its member, all right. Now, and you have a total of 5 male and 3 female, all right. Now, among these females now, these 3 females, Miss A, that's her name, refuses to be a member of the committee in which Mr. B is taken as a member. You understand what's happening now? Miss A is saying, come, if, who is Johnson? Give it up for Johnson. I see the answer and I love it. Now, Miss A said, I'm not going to be a part of a committee when Mr. B is there. All right? That's her position. She did not say she's not going to be a part of committees, though. She just said, once you have Mr. B there, I don't want to be a part of that particular committee. Miss A is not saying I don't want to join you guys. Oh, Miss A is saying when you bring Mr. B as a member, don't bring me. We don't know what happened between Miss A and Mr. B, but obviously Miss A don't want to be in the same committee that Mr. B is a part of. Now, the question is, in how many different ways can this committee be constituted? All right, in how many different ways can this committee be constituted? Now, this is quite simple, guys. All you need to do is to follow the pattern. Enoch, what's going on? Enoch said he's lost. Is it in understanding the question or understanding the answers they are producing? What's going on here is obviously just a very simple thing, right? There's a committee. That committee requires a man, and how do we design a woman self? a man and a woman. All right. Now, we have 5 males. We have 3 females. That means we can pick, out of these 5, we can pick one of them to be a member of this committee. Right? And out of this female here, we only need one. We can pick 3 of them. Now, but there's now an issue. There's one woman, of course, among these 3 female that said, "Come, I'm not against being a part of this committee." But among these male people, this male, once you don't carry Mr. B, say now Mr. B, you want use do one of the member, please no join me for there. That's the position of Miss A. You know, maybe they beef arm, or I don't know. Maybe something don't happen where, and maybe they fear arm, I don't know. But he just talk say, anyway, where Mr. B dey, abeg no carry me put for that place. Now, and you need to form your committee. So the question as a mathematician now is that how many committees can you constitute with this condition? Right? So all you need to do is to just do something very simply. First of all, select your people. Select your people. Select your people. So you get like how many people? You get 5 male. So that's 5 male. You are choosing, you just need to choose one, choose them. And someone will say, sir, you don't know, say Mr. B go fit come out from this selection, select am first. Even na only Mr. B they say make you know join the committee, and na only Miss A they fight Mr. B. So first select everybody randomly, then try select the female also. So if you want to select the female now, that means 3 female. That's 3 female. You are selecting just one also. Don't forget now, just 1 male, 1 female. Now you did this committee. Now, if you do this first, wetin you go get? You will get like 15. So you go get 15 ways. That means 15 committees. Now, but as a mathematician, you understand, say, these 15 ways, one of these 15 ways go include this selection where Mr. B and Miss A go dey. Now only one go get Mr. B and Miss A. Now only one fit get am. Shey you get? Because if you select everything, you know how combination works now. If you don't select Mr. B and Miss A, that is only one possible team that you can form with two of them. Only one possible team. So among all these 15, now only one you want to dash away. That must not happen. So all you want to do is just subtract one way, because out of that 15, now only one way you want come out. So it will be 14 ways. Are you seeing how interesting this question is? All right. So, shey we do giveaway again. No, may we wait small. May we never do giveaway. So I'm sure you understand. This is how you move through with the question. Yeah, if you say you do use another method, I've already told you before. Me, I don't have any issues with methods. Just ensure that you are moving in the right direction. Okay, if you now get this question, fine. Where I know see incorrect answers, too many, then we go do giveaway. If I don't get am, we go do another question before we do giveaway. So we're gonna take the question down. So there are 10 points in a plane. Me, I don't use ChatGPT. Just use your normal head. You know, the main point of this thing is for you to learn. So me, I don't use ChatGPT. If you use ChatGPT, that will not be part of AMO. Me, I don't use any internet or anything. Just use your mind to think this through. So there are 10 points in a plane, of which 4 are collinear. So the question be say, find the number of triangles formed formed by the points as vertices. So when I don't use any different, any object, anything, no, just give me your answers. All right. What's the answer? Anybody with an answer there? May not don't give me ChatGPT answer, or just give me, I want to know what you guys know. So you, yeah, now. You know, okay, you have 60 seconds more. We have to put a time to it. Person say 20, person say 20, okay. Person say maybe 116. Person say, okay, you know that person has said something. Person say 120, person say 116, another person say 116. Person say 120. Enoch talks say 120. Enoch. Larry talks say 116. Inioluwa talks say 116. Enoch changes answer. He talks in at 480. Reggie talks in at 120. Okay, might give like 10 more seconds. Anonymous talks in at 116. Foxy talks in at 116. Jimmy talks in at 116. Let's see, this 116 one day rain, or maybe not the answer it will be. Modular talks in at 116. Okay. So we don't get any other answer. Okay. We'll do one together. So you guys, many of you are writing 116. Knowing fully well that this could usher in. Okay, let's go on. Let's see. Look at the question. There are 10 points in a plane, of which 4 they collinear. 10 points they. 4 of them are collinear. The first question we say, what mean the meaning of collinear? Can anybody give me the definition of collinear right there on the chart? What's the meaning of collinear? What does it mean if you say a point or points are collinear? What does it mean? What does it mean for points to be collinear? Could I get a very intelligent answer there? Collinear, what does it mean for you to say something is collinear? Lie on the same plane, points that lie on the same line. Good. I think I like those answers. So collinear describe 3 or more points that lie on the same single straight line. So for instance, if you have a straight line now, you have a point here, you have a point here, you have a point here. Let's say this is point A, let's say this point B, let's say these 3 points are collinear, all right, on the same line. Good. Now, from that understanding, this person don't go type am for ChatGPT. Ademola Marvelous. Ademola Marvelous. Well done. We salute you. Now, there are 10 points. Enoch, Yusuf, you go ChatGPT. You don't say I sabi how to detect ChatGPT answers. Okay. Now, there are 10 points in a plane, out of which 4 are collinear. So among these 10 points now, that means say, like say, you get different scenario now. You get all the different other points. No, this one they collinear. In short, you just have different other points. Now, you want to make triangles by this point using them. You know, one thing why these 4 points we will mention, they're very important to note. We say you cannot use this, and if you look at this straight line now, you cannot form triangles with any of them. You cannot form triangles with them. Triangle need 3 of them. There's no how you want to form triangle with them. Maybe you can form the base of one triangle, but how do you want to get the last point? Like, you cannot. You need a point that will be around here for you to be able to form the triangle. And they said they are collinear. So these 4 different points, they don't go bring out they don't go fit bring out triangle. And the issue be that these 4 points don't go give you triangle. Now, the question be say, imagine say all these points, none of them they collinear. How you want take use 10 points form triangle normally? That one is simple, because not for you to form triangle, the vertices, you only need 3 points to form triangles. All right. So now that means say 10 points. If you want form triangle, you go need 3 out of the 10 points. All right. Normally, that means say that's 120 different ways you can form your triangles, because out of these 10 points you'll be needing 3. 120 ways go come out. You are choosing 3 out of these 10 points. Just like say, I choose this one, I choose this one, I choose this one. I don't make my triangle. I feel decide say no be that I won't choose. Say now like this I won't go. I choose this one, I choose this one. That's another one. I feel decide say I don't want even use this one. Say now like this I won't go. I use this one. So you see how you can bring out different triangles with 10 points. Now, you could not be say, imagine say these 4 points don't be collinear. Those 4 points alone will be collinear. Imagine say they don't be collinear. How do you want to make the triangles from them? Normally that will be 4 choosing 3. All right, please, can you guys still hear me? Can you indicate if you can still hear me, please? Can you still hear me? Like, because I'm seeing people say, okay, because I want to say, share YouTube never start again. Okay, that's good. So you can still see what we are doing. That's good. Okay, that's okay. So now, these other 4 points will be collinear. Imagine say they will be collinear. Them alone, how many you feel use them do? You feel use 4 out of these 4 points. How many triangles you feel form with these 4 points? Of course, you can form 4, because 4 choosing 3 out of them will bring you 4 this thing. So of course, if you want to make the total number of triangles, because these 4 are collinear, these 4 will they talk here now in case they don't be collinear. But now when they be collinear, that means you have to remove all the points. This is if the whole 10 was being used, now be 120 ways. Now, if the whole 10 was being used, you will have said 120 ways, but you have to go and remove the one that 4 would have brought you, which are now collinear. So that will be 120 minus 4. That will give you 116. Yikes. Okay, so because many of you did you were able to get the answer. So we'll do small giveaway again, Abby. So I will leave the first digit. I'm not gonna write the first digit. Now question I will use them ask you. The next one after the first digit now 53. Next one are 0, 6. We have 8, 9. How do I want to put this one? Oh? Okay. Might just put them like, okay, might just put them that way. I want to do something there, but might just leave them. 02, Okay, now look at it. Oh. This digit is square root of 16, 9 be there, 9 be there, and then the last one is 6 raised to power 2. Then the first one now 6 combination 3. Now M10, now M10, now M10 users. Airtel they come very soon, no worry. Airtel is coming. So 6 combination 353. So if you have one it, let me know. This one are digital, this one are square root of 16, this one are 6 square. Oh yeah, if you don't get them, may you show face. So M10 users. So now M10 users. So if you know they use M10, just relax. Now Airtel they use. Wow. I can they praise. Okay. How can they praise don't catch them? I imagine. Okay. That's nice. Okay, okay. You like say Olajide Isaac. Okay, you go press her, you press the better thing, but like say the thing go, you tell you say person don't use them abi. May you hold praise and praise don't use them. Anime vibe. Now you they give signal abi. You know load down, you they give signal. Okay, so let's go to the next question quickly. And give you we go still there, no worry. This question, I will see person will go get am. Let's see. It's a very simple question anyway. In a party, every person shakes hand with every other person if there are 105 handshakes. So the question is for you to find the number of person in the party. So look at the question, quite very simple and straightforward. In a party, every person shakes hand with every other person. Of course. Now, there are 105 handshakes. There are 105 handshakes. So find the number of person in the party. So look at this question now. They say in a party, every person shakes hand with every other person. That means say this person, everybody, they shake hand with at least everybody. Every person shakes hand with every other person. Now they said there are 105, not at least, sorry. Every person shakes hand with every other person. That means say, imagine say Precious Day, Victor Day, Precious go shake Larry. Larry go shake Victor. Precious go also shake Victor. Victor go shake Foxy. Everybody shall give each other handshake. Now, they said they are in the end, when they calculate the number of handshake will happen. Now 105 handshake happen. So the question is for you to find the number of persons in the party. To find the number of persons in the party. I never see answer. All of you with the right answer. I never see one answer. Now this one we're supposed to use do give away. If you guys don't cite the answer, one person don't write the answer. Okay. Okay, the answer is on the flow now. Now 15 be the answer. Oh. The answer now 15. So let's examine this question together. It's a very interesting question. I'm sure you guys can realize it. It's quite interesting. You have to be very smart to be able to understand it. Now, let's assume, of course, it's okay for us to assume number of persons in the party. Let's say it was n. That's okay. All right. And we're told already that the number of handshakes was how many? 105. That was based on the question, right? Now, look at it. If you are told to, how many people does it take to make an handshake happen? 2. So for you to say an handshake has happened, an handshake don't occur. That means there are 2 people, right? So look at this. This is a logical thing. Let's say Precious and Adebola now, they clock hand together. You say that's one handshake. If Precious go meet, let's assume, let's just even do a very small something. There is Precious, there's Adebola, and there is Enoch. How many handshake can go together in all these ones? Precious shake Adebola, Precious shake Enoch. All right, that's 2. Adebola shake Enoch, that's 3. So you can see how this handshake is happening. So understanding this, the total handshake that has happened here is what? How many handshakes don't happen here? This is one handshake. Precious and Adebola, now one handshake be that. Precious and Enoch, now another handshake be that. Adebola and Enoch, that's another handshake. That's the total of how many handshake? 3 handshake. Now, look at it. It took 2 to always make this thing. Imagine I wanted to ask myself, imagine I didn't know the number of persons. That's n combination 2, because it was taking 2. That means for me to say a team has happened, let me use the word team. For me to say a team has happened, I needed 2 people. 2 people was what made this team, handshake being the context of the team. Now it was 2 persons that made it happen. So once the handshake happened, you said that was one team. So this was one team, 2 teams. So each of these teams required 2 people. So if you look at it now, because we knew the number of people, we obviously know that this was 3 people, and we're combining 2 of them at the same time. We had 3 people. Each of the combination was 2 of them, 2 of them, 2 of them. If you go back to your calculator or use your Pascal triangle or anything you want to use, you see that 3 combination 2 is 3. So looking at this approach now, that was a very simple one. Obviously, you could easily, I wanted to bring that to you so that you can easily relate to a more higher question. Now, you're now told that the total number of handshake now 105. Obviously, to make one handshake, it was the team, or whatever you want to say, the team, the committee, whatever you want to say, you needed 2 people. So the question be say, how many people were you selecting from, that you were selecting these 2 people from, that eventually when you made all this thing, it gave you 105. This is the expression you will solve for you to get your answer. So you have a total number of people. From each of them, they were shaking hands. Don't forget, everybody shook hands. That was what they told you. So that means you used every of the possible people. Now, at the end of everything, you said your answer was 105. When you brought out the total number of handshakes, it was 105. Total number of teams, if you want to know it that way, total number of team that came out was 105. So question is, waiting can be hen. What is your hen going to be? So I'm sure you guys can solve this one. Abi, is this one going to be hard? No, n combination 2 is not going to be hard equals to 105. This is something I believe everybody in this class should be able to easily solve. N factorial over n minus 2 factorial equals to 105, right? this will be, you know how to do this. This will be n, then n minus 1, then n minus 2 factorial. You're going to stop it here because you are seeing n minus 2 factorial as the denominator. So I can easily cut this out. I have n into n minus 1 over 2. 2 factorial is 2. So I'm okay with writing it as 2 equals to 105. All right. So I'm left with n into n minus 1 equals to 2 times 105 is what? I think that's 210, right? So I have n squared minus n minus 210 equals to 0. Can you see that? We're already no longer in the basics. So I believe at this point, if you have been following these classes, you understand everything going on. There is no big deal at all. So if you look at what's going on now, I have to go and solve this quadratically. If you solve this quadratically, you will get n minus 15 and n plus 14 equals to 0. Of course, following this, you can see that your n will be equals to 15 or minus 14. So guys, can you ever have minus 14 as your answer? Is it possible for you to have minus 14 as the answer here? No, obviously. So your n can only take a positive value because you cannot have a negative answer combination too. So n here is equals to 15. Are you seeing how nice and simple these things are? Okay, now this next question is something I will tell you also. You need to really be very it's every question you'll be solving now. Everybody in this chat, in this class, can answer it if you have been following the classes. They are all, the only point now is you'll be getting word problems, so you have to be able to interpret your question the right way. That's the only, and that's the advantage of solving many questions. So you get very exposed. So in the end, you are very used to different questions. So whatever comes out in your major exam, there's nothing hard at all. You know, one thing I'm seeing, and I'm sure you guys should be able to relate with me. I believe at the point when you are doing your exam, questions are going to be so simple that you guys are going to be wondering if you are actually writing your major exam or not. That's what I actually believe. With this level of exposure, I don't see you having issues at all. At all. I don't even see it. I'm going to tell you the very honest truth. I don't see you having issues at all with questions. I believe you would come out of the exam hall and you'll be so surprised, like, can an exam be this simple? That's what I'm actually envisioning, because I feel this level of exposure is too much for you to have issues with any exam. Like, you can't see questions outside this scope. This is a very wide scope of technicality being exposed to you. So look at this question. Guys, can you still hear me? Are you still there? Can you guys confirm if you can still hear me? Okay. All right. Now look at the question. Please take your time and take a deep breath while solving this question. Don't be in too much haste. Find the number of positive integers which can be formed by using any numbers of digits from 0, 1, 2, 3, 4, 5 without repetition. Enoch, dial it down with Arsenal fans. Dial it down with Arsenal fans. I don't. You want to call them out, but Enoch. Your breath is too deep. Miracle. I don't understand. You guys are shooting. Have you even solved that? Or how do you guys? I don't. What's going on here? I'm like, it looks like you guys are too hot now for JUPEB exam. The way you guys are shooting answers, I'm wondering if you're like working calculators. You know, don't turn cash you. So find the number of positive integers which can be formed by using any number of digits from 0, 1, 2, 3, 4, 5 without repetition. Look at the condition there. The number of positive integer, look at it, positive integer, that means we don't want negative, positive integer, which you can form by using any number of digits from 0, 1, 2, 3, 4, 5 without repetition. Is Daniel in this class? Daniel in class 2, is he in this class? Is Daniel in this class? Daniel, guy. Daniel. Daniel. Is he in this class? Okay, we have different answers, 3,600. Okay. I can see Omojola's answer. Can I get all the answers? Find the number of positive integers which can be formed by. If you guys give me good answers, we'll do Airtel giveaway. We will do for Airtel. So Airtel users, brace up. Your time is coming. If you guys supply me better answers, those are better answers I define. Oh yeah, we're waiting. Person talks 1,630. Let's see. Let's see if that's going to be the answer. Okay, so do we have solid answers yet? Waiting, Jimmy, they talk. 1, 2, 3, 6. Okay. Do we say Daniel was there? I don't know. Are we hearing from Daniel at all? Okay, one. That means you guys found this question quite. Okay, someone said 1, 2, 3, 7. I don't know how they get 63. It can't be like say you did 63. And person get 1630. You know what I say now? 1630. So it's just not be the middle value of Inioluwa's one you get. And you still dey on point now. At least you get waiting dey other people's answer. Okay, let's solve together. It looks like I didn't get so much answers here. And that's the reason why we are doing all of this, because you can imagine person get 120 and you still get an answer now. Everything an answer. Now look at number of positive integers which can be formed. Look at the way you guys are going to do this thing. It's very simple. That's why we're doing this anyway, and that's why I love that we're doing this, because at least we have the opportunity of exposing you to lots of questions. Now look at it. You want to make positive integers by using any of the numbers of these digits. Now guys, number one, you can have different kind of, for instance, you can have one digit integer, for instance, one digit integer, positive integer, don't forget. Abi, can you not? So you can have one digit positive integer. Values that are one digit positive integers, for instance, you see 0. If you say 0, 0 is not part of it, because that's not part of what we call positive integers. Now, but apart from 0, we can have 1, 2, 3, 4, 5. So you can see that these are part of the positive integers that can be formed. This, you at least you are not wrong if you do this. These are positive integers. Good. So that means say for 1 digit positive integer, 1 digit, that means the one we just get 1 digit alone. We don't get past 1 digit. You can see that obviously you can make 5 of them. I just wrote them out. There are 5 possible scenarios, and you don't need to be asking me what are the 5 possible scenarios. 1 na one of them, 2, 3, 4, 5. That's for 1 digit positive integer. So now 2 digits positive integer, 2 digits. Now let's try and deal with 2 digits. Now, what are examples of 2 digits? Now, for instance, look at it, guys, look at it. 2 digits. Please don't say 01 is 2 digits. It's not part of it. This one will be, all these ones your waiting be the name. Now your test markings be all these ones. 01, 02. This is not how we write numbers. You know that already. So for 2 digits positive integer, let me just give some example. You can have 10, you can have 12, you can have 13, you can have 14, you can have 15, you can have 20. Don't forget, you can have 21, you can have 22, and so on. Now, this is me trying to be manual, but you don't have to be manual. You can use your normal understanding. So let's try and use our normal understanding. So let's say we have 2 digits. The question, you know, there was a time when I was explaining one method when we started these classes. I told you that you need this other method. Look at one of the reasons why you need it. For you to arrange these first digits of all these digits, like this is the first digit now. You can see these are the first digits. I didn't write every other one. You know, you can still have so many other ones. But let's try and see how many ways can you arrange the first digit of, if you are trying to arrange 2 digits, how many ways can you arrange this first digit? Now, guys, you can arrange this first digit using 5 ways, because 0 cannot be one of it. I told you, you cannot have 0 as this first place. You can only have 1, you can have 2, you can have 3, you can have 4, you can have 5. You can only arrange this in 5 ways. This is 5 ways. I'm sure you understand that. Now, the other thing also, this second digit, like this second one now will be the second one. We can have it in how many ways? Look at it. Look at it. Don't fret. It's very simple. If you don't write 1 for here, don't forget this rule we talk say without repetition. That means say you cannot repeat. If you have written 1 here, you cannot write 1 here again. You have written 2 here, you cannot write 2 here again. You must only use it once. Now, even though we said this one can happen 5 ways, remember we omitted 0 because we did not want to have we cannot have 0, 1, all these things. So normally we have 6 digits there. So this one can happen in 5 ways. But this place, how many ways can this one happen? How many ways can this one happen? This one can happen in 5 ways also. I will explain why. Why is because normally you want to say this one can happen in 6 ways because you have possible 6 digits that you can put here. It's true you can put 6 digits here, but don't forget, among these 6 digits, you have written 1 here. One of the once you have put a digit here, you cannot put it here again. So that means if you have written 1, you see you don't write 1 1. So I cannot write 1 1. So look at for the 1 scenario now. After I've written 1, I could only write 0, 2, 3, 4, 5. That's 5. For the one for 2 also, 2, 2 is not permitted. So I can only have 2, 3, 2, 4, and 2, 5. If you count again, 1, 2, 3, 4, 5, you can see it's 5 ways you can arrange this one. So you can arrange this one in 5 ways, you can arrange this one in 5 ways. The reason why you can arrange this one in 5 ways is because 0 cannot be there. But you know 0 can still be here. So if you do this 5 times 5. So that means the 2 digit positive integer can happen in 25 ways. Are you seeing it? Nice and simple, right? I'm sure you guys are enjoying it. You are enjoying. You would love to see something like this in your exam. Tell me, right? You would love to see something like this. Now, let's quickly talk about 3 digits. Because that's what we're going to do. These things now step by step. Don't be saying you go to do rush or anything. Just move step by step. Now, For 3 digits, that means say you want to have like this. Is Iyioluwa here? Prestige Iyioluwa. Is she in this class? Now we have 1, 2, 3. All right. So this first one, of course, you already know how this thing goes. The first one can happen in 5 ways. You know that one already, because say you cannot put 0 there. You're having 6 on different numbers, but you can only put 5 here because 0 no go fit dey here. Now for this second one, you can only arrange it in 5 ways. You already know why. Because once you have written something, you cannot write it here again. Even though you have 6 different options to pick from, this second one can have 0, but since you have written anything here, you cannot write. So it's 5 ways that are possible here. For this last place, if you have written something here, you have written something here, you know, say you don't get, you already have, you are only left with 4 numbers because you have written something here. Let's say you have written 1, 2. You cannot go and write 1 and 2 again. So 1 and 2 is already off from what you can write as the last one. You only have 0, 3, 4, and 5. So this one can happen in 4 ways. You can feel it. You understand what's going on there. It's practical. This is something you can understand practically. So if you say 25 times 4, 25 times 4 will give you, that means there are 100 different ways you can have 3-digit positive integer. You are seeing that bar? Good. Let's do for the 4 digits. Don't forget, we go do and reach 6 digits, because 6 digits, you are told to find all the total positive integer you can bring out here. Let me just tell you this. This is a positive integer. You can write, this is a positive integer. If I write 5, 4, 2, 3, 1, 0. 5, 4, 2, 3, 1, 0 is one of the things you can bring out. You can see it's 6 digits. 6 digits is the highest you can have. You can't obviously have 7 digits because you only have 6 numbers. So let's do for 4 digits positive integers. Let's see the number of 4-digit positive integers that are possible, right? So we have 5 can happen as the first one, 5 can happen as the second one, 4 can happen as the third one. Can you guys tell me what can happen as the fourth one? You have used something, and don't forget there is no repetition. This one will be in 3 ways. This one will give you 300. For the fifth 5 digits, for 5 digits, look at, for 5 digits positive integers, this would happen in 2 ways, because you have used, you will only be left with 2. That will be 600. And for the 6 digits, this will be what? Times 1. The last one can now, only 1 more will remain, because if you have used 1, 2, 3, 4, 5, you're only left with 1 more digit left. So it will still be 600. Go on and add all these things together. What do you get as your final answer? Don't forget, these are the total. This is 1 digit, 2 digits, 3 digits, 4, 5, 6. If you add all this together, you will be having 1,630. So give it up for people that got this answer, 1,630. Airtel user, where are you? Where are you, Airtel user? Let's talk quickly. Airtel users. So Airtel users, say after me, my time has come. Let's get religious a little bit. My time has come. Okay. I'm sure you're gonna go church today, Sha. I'm sure many of you said my time has come. Okay, so we have this 51 76 05. Okay, might not talk am, make people dey see am. I go leave this space. I will leave this space also. So you know, I will solve for that place. This is 7 combination 2. And this is 8 combination 4. Oh yeah, oh yeah, oh yeah. Who get am? Who catch am? Who catch am? Who catch am? Anybody don't catch am? Wow, goodness. Wow, after after all this many this thing. Okay. Congratulations, goodness. That's nice. That's nice. Uh person talk say my recap. You know wetin happen? When this video will be available tomorrow, I believe latest by 12. So you guys will have the opportunity to. So we have just about 2 questions left, guys. Let's finish this up so that we know. Don't forget this is the last and the last class on permutation and combination. So let's just finish this up. Let's try and be fast. I don't mind. Let's hurry up so that we can leave you on time. You guys have really, 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 really tried. You guys have really, really, really tried, and I'm really, really glad you made it through because these are some of the moments that will count for uh, praise. If you miss this question, we'll stay here till like the next 2 hours. Praise. If you miss this question, because this one way they, I don't know waiting happen. You and your bed, waiting happen. Praise. We still get MTN, no. We still get MTN, we still get Airtel. Even at the final, we will do that one. This question is another level of technicality again, obviously. I don't think you have seen a type of this. So try and solve it. So this question, it comes with another. You would see how the question went. Look at it. They said there are 10 persons among whom 2 are brothers. The total number of ways in which these persons can be seated around a round table so that exactly one person sits between the brothers is equal to what? So this is one of those questions you have to be very careful of. It gives you so keep solving that while I write this question. So you guys, I will give you an announcement at the end of this class. Very important, very, very important announcement. So look at this question. I'm trying to push these two together. Okay, so we're having lots of different questions, different answers there, and I was hoping you guys will unify at one answer. So the question said there are 10 persons, among whom 2 are brothers. Now, the total number of ways in which these persons can be seated around a round table so that exactly one person sits between the brother is equals to. What did you say your answer was? A. That's quite large. Wow, none of you have gotten the answer. Is that not funny? Wow, you guys should not fall my hand though. I'm not seeing the okay. Looks like I see the answer somewhere. Okay, I see someone that has gotten the answer, but almost all of you did not get the answer. Wow. Wait, why am I not see really what's going on? You guys don't are you seeing exactly why? Anyway, so my thoughts and fear is that what if this is the question that comes out with permutation and combination? Wow. Anyway, that's why we still have more time to prepare. So look at this question. There are 10 persons, among whom 2 are brothers. So the total number of ways in which these persons can be seated around a round table, guys, round table. Note that, round table. This means that you cannot, you know the theory around the round table. So just note it now because I want to rub this place up. You have 10 people and 2 are brothers. Now, how many ways can you see them in such a way that one person must sit between the brother? One person must sit between the brother. That means now that you have gotten the question, let me rub this place up and let's try to solve it here. So we have 10 people. 2 of them are brothers. The pictorial form of this is like this. Let's say we have brother A, brother B. This is a round table now, right? We have someone here. They said there must be somebody between them. They said somebody must sit between these 2 brothers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is like a picture that can reflect what we're dealing with. It's around a round table, but they are telling you that these 2 brothers, somebody must sit between them. That's the condition. So the question here is, how do you solve this? Guys, don't forget what I taught you guys when you are dealing with something where they said there must be something, someone must be close to each other. You're going to take this object more like a one object scenario. Now, although when I say one object scenario, this will still be changing. This one in between can change, but these settings is not going to change. That means this is the meaning of that. Wherever you take A and B to, you must take one space in between. The space for one object must be between 2 of them. So in the end, this is your permutation is still going to permutate this. They're permutating everything, every of this cycle, including this, but the settings must include this. So that means the object you'll be shaking all over the place, because you can shake this A space B, A free space B. You can bring A and B here. There must be that space in between them. So this is like going to be held as one thing that must move anywhere. Anywhere A and B is going, that space must be in between. So that means you're going to see this as 1, 2, 3, 4, 5, 6, 7, 8. Is it 8? Wait, 1, 2, 3, 4, 5, 6, 7, 8. All right. Is that going to complete? We said 10 brothers. So now look at it now. You're going to be permutating this 7. This 7, you're going to be arranging them in different ways. You're going to be arranging this in different ways, and 1, 2, 3, 4, 5, 6, 7. So this should be your answer. I understand we are running out of time. So 7 factorial multiplied by, the person that did 10,008, 10,080 is actually correct. So these 2 factorial factors in the fact that you can have BA or AB. All right. So can anybody give me the answer to this question quickly? This one here, can you give me the answer to that very quickly? Not wasting time. Okay, what did you get as the answer there? Wow, I've not seen an answer yet. Oh yeah, give me an answer. A letter lock consists of 4 rings. I'm sure you know this kind of scenario when you have maybe your bag. There is a lock, there's a lock, there's a lock, there's a lock. You keep shaking it. So 4 rings. Each ring contains 9 non-zero digits. So you shake this ring, you can have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 non-zero. That means 0 is not part of it. All right. Now, each of the lock, that means this one has 9, this one has 9, this one has 9, this one has 9. This lock can be opened by setting 4-digit code with the proper combination of each of the 4 ring maximum. So it's possible for you to have this one. Your code could be 2816. That may be your code. and you understand. And once you can only open this lock obviously by setting the correct one. So the question now is that how many codes can be formed to open the lock? How many code can be formed to open the lock? So imagine you don't have any scenario where your bag will get probably, maybe, okay, maybe this letter is a letter lock, so it will jam or something. So imagine you have to keep trying. What number of codes will you have to do for you to at least one of them should be the answer? Okay, looks like I'm seeing the answer, and I like to see the answers. I like to always see the answer. So somebody said 6561. That's actually the correct answer. This is supposed to be quite easy because what you just have to ask yourself is the first lock, the first ring can be arranged in how many ways? 9 ways. You can have this in 9 ways. The second something, how many ways also? 9 ways also. The next one, how many ways? 9 ways. The fourth one, how many ways? 9 ways. Sorry. So obviously, it's 9 times 9 times 9, and that will give you a total of what did you call it now again? 6561 bar. So this is 9 raised to the power of 4, which should give you 6561. So guys, you have one more. This is the final one. Don't worry. Then we'll do the last giveaways, and then that's all. This I don't want to push this question anywhere. You have to just do it. So guys, you've come this far. You have to just try and see it through. It would not be nice to carry this question anywhere else. I would have. Do I attach something to this question? Where is Praise? Is Praise still here? So somebody is asking, so you guys should keep solving this while I'm trying to respond to the question somebody just asked. I need to respond to it. So somebody's asking if we're going to be doing this physically. Well, we're going to be doing it physically, but I told your leaders already, we're using the system that we always use majorly when we get into the second semester, and that's the presentation. So you guys are going to be presenting for us. So you'll be presenting now. You guys will come and teach everything we have taught. You understand? So now I'm the one teaching. You will be the one teaching that time. Any of you can come out and explain all these things. So you come out, you explain all these things and give us you give us vibe. So me say like that time I will sit down also, like I will be like almost student. I will sit down, they watch everybody. Me say will they listen. So but this the thing is say if you want to teach us wrong thing, we will come call you out. Yeah. Me no spoil our the knowledge right there. I mean say that they correct. So that's the way it's going to be. We would sit down, we'll watch you, and you guys would answer questions and everything. So this is the grand finale for the classes on permutation and combination, guys. Next week, as I say next week, this week, you'll get the information about the next topic, probability. Very, very important. But this is the finale on permutation and combination. I believe I answered the question of the young guy that asked. So how did you solve this question? What do you do to get 4? You should see now 4 be the answer. So just for the sake of those of you that probably need to understand it, if you remember your n permutation r, it was equals to n factorial over n minus r factorial. Your n combination r was equals to n factorial over n minus r factorial. This tells you already that n permutation r is equals to n combination r times r factorial. So how did you solve your own, by the way? So n permutation r will be equals to n combination r times r factorial. If you want to prove this right, you can go on to try it here. N factorial over n minus r factorial, which is n permutation r, is equals to n factorial over this n combination r over n minus r factorial. This n combination r, this is n factorial, n permutation r. This is n combination r, this is n permutation r. So look at what I said. I said n permutation r is equals to n combination r times r factorial. So you see that this will cancel this, and you see why I said this is equal. So this is a very good expression. You can always use that somewhere else. So that means if I have something like this 6 permutation r, that means 6 permutation r will be equals to 6 combination r times r factorial. So this is obviously 360, that's 6 permutation r, is equals to 15 times r factorial. So r factorial there will be equals to 360 over 15. That will be equals to what? 24. So r factorial equals to 24. And I'm sure you agree with me that 24 is the same thing as 4 times 3 times 2 times 1. And this 4 times 3 times 2 times 1 is what we call 4 factorial. So obviously you can see that your r here is equals to 4. Okay, now it's time for the final giveaway. So let's do for Airtel first. Airtel users, how are they? Okay, so Airtel users, where are they? Okay, let's 5929. Airtel users 5929, or do you want me to write it? So we have 5929 6603 1796 14 then 6 combination 3. All right, that's for Airtel users. So M10 users, where are they? In an almost sleep, Abby. No wahala. This is for MTN. I don't see that MTN. You get many highs on. Now zero be this, so when I no talk, say I don't see am. All right. So what do we have? Oh yeah, Airtel. You don't catch am. Let me hear you. Oh yeah. You know, say you don't catch am. Airtel users. Let me hear you. MTN. You don't catch am. Let me hear you. Praise. Can you imagine? Praise don't do am again. Airtel. Anybody don't catch am for Airtel? Wow, Foxy. Foxy. Okay. Wow. Okay. So that was great. Praise. How fast was your finger that you were able to catch 2 out of the whole thing? Anyway, guys, it's been a very great moment, been a very great time. You guys have been very, very wonderful. I love the feedbacks, I love the answers, I love your energy. And this was really great. And this is, of course, the grand finale. We have we've covered, literally touched everything on permutation and combination. So the next thing now is for you to prepare very hard and ensure that you are ready for exams. Now, this is the information I thought to pass to you before you leave. Prepare for a speed and accuracy test once you resume, and it's going to be CBT. So I'll tell you the formality very soon. You're going to be doing a CBT exam, a test when you resume. Don't worry, you will learn about how it's going to be. It's going to focus majorly on this topic and probability. All right. So I'll tell you the modality very soon. So guys, this is where we're going to stop it for tonight. Thank you for joining. Thank you for your participation, and thank you for everything. You'll get information, and we'll be seeing each other in a bit. Thank you guys. Bye bye.